All right, so let's have some picture in our mind when it comes to forces of rolling. So you can see, on the left hand side, it's mentioned that there is kinetic friction during sliding. So a lot of emphasis is given to smooth rolling, where A com is equal to alpha r, and it arises, and the torque which is supplied for this angular acceleration comes from static friction. Now, a distinction needs to be made. When you have sliding, which is generally in the part one of the motion, you can look back into previous videos where the motion has been divided, where there is some sliding and and rolling, and then it becomes pure rolling. So there is kinetic friction during the sliding part. If an object, for example, has no rolling, it will only have sliding. So you can see the conditions for kinetic friction that during this phase, the linear acceleration is not equal to the product of alpha into r. This is only true when you have smooth rolling and linear acceleration becomes equal to product of alpha and radius of the body. Generally, we write radius because we're dealing with cylinder, spheres, disk, and rounded shapes. So remember this concept, which friction appears during which part of the motion.